So the SAT is getting harder every single year, and these are 3 of the hardest questions you will see on your next SAT. So this is what the first question looks like, and before we get started, guys, we all know SAT is an exam of repetition, so you want to be well prepared for these 3 types of questions. And the best way to do so is by trying them with me, so I'm going to link in the pinned comment. Make sure you print it out and try with me for the best results. And we're going to go over these 3 questions in the order of increasing difficulty. So the first one is not going to be too bad, but the third one, it's one of the hardest questions I've seen in a very, very long time. So let's get straight into it. The question says, in the given system of equations, P is a constant. If the system has no solution, what's the value of P? So in the system, we have 2 lines because all the x's are to the first power. And on the SAT, when you are given 2 lines and it's asking for number of solution, it's asking for the number of intersection. And how do we find the number of intersections for 2 lines? Well, we use something known as the matching rule. I'm going to link in the pinned comment as well. And how you do it is you align the x, y, and the numbers and you compare their ratios. So here's how it works. So if I move this to the other side, I'm going to get 6 over 2y minus 1 over 4x is equal to 2 over 3. And for this one, I'm going to move y to the other side, minus py plus 1/2 x is equal to 6 over 2. And now that our y's, x, and the numbers are all lined up, I'm going to compare the ratio of the coefficients or the numbers attached to these variables. And according to the matching rule, the ratio of the y's and x must be the same. So for y, it's going to be 6 over 2 over minus p, and then for x, it's going to be negative 1/4 over 1 over 2. And we know that they have to be the same in order for there to be no solution. So now we're just simply going to cross multiply. We're going to get 6 over 4 is equal to p over 4. Which means our p has to equal to 6, so our answer is going to be 6. So the main takeaway from this question is when you're looking for a number of solutions between 2 lines by looking at 1 and 1 over here, we have to use something known as the matching rule. It's very popular on the SAT, but as long as you got the matching rule down, you'll be good to go on these types. This one's a little bit funky, but let's go straight into it. So we're given 2 graphs right here, and the question says 2 data sets of 23 integers are summarized in the histogram shown. For each of the histogram, the first interval represents the frequency of integers greater than or equal to 10, but less than 20. So this first bar right here is going to be a number that is greater than 10, but less than 20, and that's how many there are. In this case, it would be 3. And the second interval represents the frequency of integers greater than or equal to 20, but less than 30, same thing, and so on. So what is the smallest possible difference between the mean of data set A and the mean of data set B? So that was a mouthful, but let's break down exactly what you need to know for this question. So what we're comparing is we're comparing the mean of data set A and the mean of data set B. And if you think about it, let's say there's a number line. This is like a small number and this is like a really big number. And let's say the mean of the data set A is located here and B is located right there. If that's the case, they have a pretty big of a distance, right? But what we're looking for is the smallest possible distance between the 2 averages. So we want A and B to be as closest to each other as possible. But the hard part is, how can we make them as closest to each other as possible? Well, that's where understanding this histogram comes into play. So if we look at this histogram right here, we know that okay, we have how many? We have 3 numbers that is greater than 20, but less than 30. So somewhere between 20 and 29. And it goes the same for 30 to 40. There's about 4 numbers here and so on and so forth. And if you compare the graphs of A and B, they essentially look identical. They have same distribution, but the only difference is that graph B is moved to the left a little bit and it's using smaller numbers instead. Whereas there are 3 numbers that's between 10 and 20, graph A has 3 numbers that's between 20 and 30. And from that, we know that because graph A is using bigger numbers, then we know that the graph A's mean is going to be bigger. So on a number lines for visuals purposes, we know that our A's average is going to be somewhere in the upper side of the number line. The mean is going to be bigger. And when it comes to data set B, it's going to be smaller because we are using smaller numbers. So it's going to be somewhere around there. So in terms of the number line, we know that our average is going to be somewhere in the upper range for data set A. We know that it's going to have a big average. But when it comes to data set B, it's going to be smaller than compared to data set A because we are using smaller numbers for data set B. And as we discussed before, we don't want the means to be far away from each other. We want them to be as close to each other as possible so that they have the smallest possible difference. So what that means is for data set B, we have to maximize the mean for data set B, and for data set A, we have to minimize the average. That's the only way to keep them as closest to each other as possible and keep the difference as small as possible. So let's start with dataset B. How can we maximize dataset B's average? Well, we can use any number between 10 and 20 for the first bar graph right here. But to maximize our average, we're going to use the biggest possible number for the first graph, which is going to be 19. And same thing for the second graph, we're going to use 29, 39, and then 49. And for dataset A, we're going to do the same thing, but go the opposite way. We're trying to minimize the average of dataset A. So we're going to use the smallest possible number possible. So we're going to do 20 here, 30 here, 40 here, and then 50 here for all of these values. And to find the average, I'm just going to add up all these numbers here, and you are going to get 887, and we're going to get 910 over here. And to find the average, we're just going to divide it by 23 for both of these numbers. So for dataset A, we're going to get 39.56. And for dataset B, we're going to get 38.56, which means their difference is literally just going to be 1, which means our answer is going to be choice B. So the main takeaway from this question was, in order for me to minimize the difference between the two averages, I have to maximize one of them and minimize the other one so that they are as closest to each other as possible. And for dataset B, we use the biggest number possible. And for dataset A, we use the smallest number possible in order to minimize it. So the hardest part about this question was making the idea of maximizing and minimizing click in your head. It might take you a minute or two for it to all click, but if it does, it's going to stay with you forever. So if it's not making any sense right now, take a second, look at the information, chew on the question a little bit more, watch the solution a couple more times, and if not, leave me a question in the comment section down below. I'll try to help you out. And last but not least, let's go to one of the hardest questions I have ever seen on the SAT in the past 10, 11 years. So the question says, two identical rectangular prisms have a height of 90 centimeters each. The base of each prism is a square, and the surface area of each prism is going to be k centimeters squared. If the prisms are glued together along the square base, the resulting prism has a surface area of that much right there. What's the side length in centimeter of each square base? So when it comes to the geometry questions, the very first thing you want to do is to visualize what the question is telling you, because it's going to allow you to see what you couldn't see before when you were just kind of imagining it in your head. So always draw stuff out. So first, we have two rectangular prisms that are kind of right next to each other. And second, we have another situation where we have these two prisms kind of just stacked on top of each other. And because we're talking about surface area, let's go over surface area for each of these types. And measurements wise, they're going to have a height of 90, so 90 and 90 here, and a square base, but we don't know what the side length is, so I'm just going to call it S and S like so. And because the question is talking about surface area, let's start there and see where it goes. So the surface area for a rectangular prism is going to be made up of the base at the bottom and base at the top, and that's going to be just S squared, and we have two of them, so we have 2S squared, and also the side of the prism, like the front and the back portion. And each of them is going to be 90 times S, and we have 4 of them, so it's going to be 90S like so. So surface area for one of them is going to be 2S squared plus 360S. And because the surface area of one prism is going to be K, that's going to be set equal to K. And because we have two prisms right here, we just multiply it by 2. 2K is equal to 4S squared plus 720S. That's the total surface area for both of these prisms. Now let's go to the second type where they're stacked on top of each other. They have the top and bottom base. So the surface area is going to be 2S squared plus all the sides. So we're going to have 1, 2 more in the back, 6, 7, 8. So it's going to be 8 times 90S, which is going to be 2S squared plus 720S. So that's going to be the surface area of this stacked shape. And we know that the stacked shape has a surface area of 92 over 47K. So it's going to be 92 over 47K like so. And what do we see here? We have two unknown variables and we have two separate equations, right? So we're going to use system of equations and play around with the equations and find out what our S is equal to, because that's the side length we are looking for. So first I'm going to bring these two together and it's going to look something like this. We have one over here and then we have the other equation like so. They almost look identical except that we are using a fraction for the bottom equation. So I'm going to change the top portion into fraction as well. So 2 is same thing as just 94 over 47. And if we subtract it out, we get 2 over 47K is equal to just 2S squared, because that goes away, that goes away. And if we multiply by 47 over 2 on both sides, 2's cancel out, we get K is equal to 47S squared. And from the work above, remember that our K is equal to this portion right here. So I'm just going to simply sub it out. K is equal to 47S squared, or 2S squared plus 360S is equal to 47S squared. And we get 360S is equal to 45S squared divided by both sides. And we're going to get our S is equal to just 8, which means our answer is going to be choice B. So the main takeaway from this question is recognizing that when it comes to a geometry question, the very first thing you want to do is for you to visualize what the question is telling you, because that's going to point you in the right direction most of the times. And more importantly, when your equation has two unknown variables and you have two equations you are working with, that's when you can use systems of equations to find out what one of the unknown variable is. In this case, we were looking for the side length of S, so we just found out what S is. And it's not a matter of memorizing how to do this question, because this question is never going to show up again. However, a question based on this logic over here that we just talked about, that is what's going to be tested. So make sure you focus on understanding and learning that concept. And on top of these 3 questions, there are 4 more questions I think you should know for your next SAT, which you can get by clicking this video right here.